Swayam Prabha. Digital India. Educated India.
So, welcome to this session. My name is Milind Atre. I am the professor in Mechanical Engineering Department and also an associated faculty with DS School for Entrepreneurship at IIT Bombay. I was also the in charge of the business incubator at IIT Bombay, which is called as SIGN. And also I was the Dean R&D of the IIT Bombay for almost 4 years. In that capacity, I have seen various technologies being transferred, licensed, startups have taken off, and therefore my lecture here is basically, based on my experience as the head of the business incubator for almost 6+ years and also as a Dean R&D for 4+ years. So this lecture is basically aiming at technology assessment, development and deployment, which are the key important area that entrepreneurship should understand in order that his technology in the lab goes for commercialization and of course becomes a very important business venture. Now this assessment is very important and I have to understand as an entrepreneur where I am. Should I go further, stop here? Should I pivot from here? Or when should I go for deployment? When should I look for investment? I just maybe would like to have 1 or 2 stories on this. If I talk about James Watt, the most famous inventor of the steam engine, that he had of course identified the right technology, but then he could not make it to marketplace. He actually struggled to bring it to the marketplace, and he understood that he required mentors, and therefore what did he do? He joined the University of Glasgow as a humble scientific instrument repairer, and he was mentored by professors, improvised an existing technology and formed a company called Bolton and Watt Company. This triggered the industrial revolution and made an interesting read, and you can actually see that now how famous that innovation has been. So it was at the right moment that he decided that yes, I need now focus on development, and went to the mentor, used his laboratory and further worked upon his invention and brought it to commercialization. Similarly, I know a case at IIT Bombay where the students really came with product A initially, and then they understood that this product A will not work and shifted to product B or pivoted to product B, which also did not work. But the students were smart enough to understand now they should move on a technology which actually makes a business case for them. So again they started from basics, cleared their basics, understood at this level based on the experience that they've had that this is the technology that we actually need to go for right commercialization. So they came to our business incubator. It was not a very big idea, it was a very simple idea of using a right motor so that the efficiency of the fans increase to many folds. And these are the famous people of Atomberg company today. The fans of this company are used almost everywhere in India, including at IIT Bombay in all our hostels. So these are right people, right team. They had to at least go to a level where they understood now this will make a correct business case. They got investment, they got funded, and they got commercialization at the right moment. But of course, for that they have to go through a lot of exercises. So the focus here is on to understand how do I assess my technology, how do I develop my technology in order to make it sure that the commercialization of this technology, this product is required in the market, and the commercialization of this will be very successful. So from this point of view, I believe that there are many promising inventors, researchers, entrepreneurs, but the technology commercialization cannot happen because they cannot come to a right judgment at the right time, and therefore they should understand at what right time they should launch this development further and go for commercialization aspects of this technology. So this actually teaches a lot of things. How do I understand that I should join a business incubator from my laboratory? The laboratory to go to commercialization can go through various ways. So one has to really understand that this much development only can happen through lab, this much development only can happen through a business incubator. But unless I go to the industry, unless I see the reality picture, my technology cannot be commercialized. So these are the things that one should assess before one lands up in a proper place. So from that point of view, what I want to talk about is the TRL level. The lecture is aimed at understanding the technology readiness level, and it's very important for me to understand the TRL level of my technology, the technology readiness level. I would like to talk about that in this lecture. Then I would also like to talk about my approach to these TRL levels, because I talk about TRL 0 also. Then I will draw your attention on one of the case studies that I've been looking at, I've been guiding, I've been mentoring to one of my students, and formally summarize it later. So the discussion is now actually being focused on the TRL level. Apart from my personal views, as I said, I would like to give an example of this later and talk about a new technology developed in our laboratory for having ultra low temperature freezer, where I will give the case study of this. So if I talk about TRL concept now, this TRL concept is not very old, but not very new also. The TRL concept actually came from NASA. So the origin happened from aerospace and defense in around 1970. It was NASA which developed this TRL framework in 1970s to standardize the technology assessment for complicated space mission. As you understand, in space mission there are different aspects. There's the engine development, there's the propulsion development, combustion development, material development. So many developments are going to be there, so that the efficiency is on high, and of course the weight that goes in the flight has to be minimized. So from that point of view, in an ambitious space mission, there are many technologies competing for grants. They're at various levels also. But when the technology gets ready, because the people's lives are actually questionable here in this case, so one has to be very sure that this technology is ready for now further commercialization. So technology first has to be assessed, technology has to be developed first, and then one can think about having it commercialized. So in 1970, in order to standardize this technology assessment for space mission, TRL actually, the name technology readiness level came, and actually that become over a period of time standardized. So TRL, what is TRL? It's basically to understand the technology assessment. TRL about understand the technical maturity of a technology during its acquisition phase. So I have to understand how matured my technology is, and can I take it ahead? Can I take it further for development, and can I then go for commercialization? So during the 80s and 90s, the TRL gained popularity in automotive. Going from NASA, it went to automotive, energy, and healthcare, etc. So this is kind of a stage gate approach that the TRL takes. That what happens when the seed grant gets funded, the projects are assessed, and there are two technologies are ready, let's say. In order to differentiate between these two technologies, I have to understand what are its TRL levels. Which one should I pick up? Has it been assessed correctly? Has it been developed correctly? Has it faced the reality of the environment that it should go in? And then only it can get commercialized. So should I pick up technology A or a technology B? And this is where the TRL assessment has to be done. So technology assessment therefore further leads to technology maturity, and then comes acquisition of this. So while talking about this technology from space perspective, the TRL gained popularity, this word gained popularity in automotive, energy, and healthcare also. Alright, so assess technology readiness assessment led to technology readiness levels, and then further it went into launch vehicles. It was adapted in Homeland Security Agency programs, and therefore this 1970 TRL concept actually got over a period of time acquired uniformly across in the USA. So in the 1990, the United States General Accounting Office, GAO, produced an influential report that examined the differences in technology transition between the DoD and private industry. And therefore, it is very important that whether my technology should go from my laboratory to the private industry for further commercialization or making big in number will depend on this TRL number. And TOD found that there was a lot of risk if you transfer technology at very early stage and go for commercialization. So they adopted a very important stage gate approach, and this is what we are going to talk about this today. If I went further, in 2000, in the year 2000, this TRL achieved a kind of formalization and standardization. And if I say TRL at level 6, it meant a particular thing overall. So it got approval from various agencies, from NASA, it went to ESA, that European Space Agency, and this word of TRL got sort of formalized. And in 2010, various companies and R&D institutions also started using TRL assessment to prioritize. So R&D institutes, the companies, the industries also adopted this word to ask what is the TRL level of your innovation. So in order to basically take it ahead, they started questioning. For example, today also when the industry comes to our office here at IIT Bombay, they would ask the question, what is the TRL level? Is it at lab level? It is at pilot level? And therefore, this TRL came with a distinct number, and this is what we're going to talk about today. So now, I will talk about using TRL and its prioritization. The TRL further continued and got evolved. This word of TRL, its assessment have become more sophisticated now in the evolution process. Almost in 2020, when 2010 industries adopted, now this assessment have become more sophisticated. They got emergence of new technologies has prompted the adaptation of TRL framework for them. So there are online tools for developing mockups now, storyboards, there are wireframes, and this drastically altered the mass of project management and consequently how the TRLs can be used. So this TRL has got uniform approval and the concept has got standardized. There are a lot of other tools that have come actually to designate what are your TRL levels, and therefore the success rate have possibly have increased, but yes, we need to have a lot of data to come to those conclusions. So what is technology readiness? So I'm talking about now the different TRL levels, and as you can see, the first is knowledge development, wherein I will say first TRL 1, 2, 3 will come up to. So in the knowledge development part, I will say what are the basic principles observed, technology concept formulated, experimental proof of concept is developed in the laboratory. Then comes technology development, and technology development should actually happen in relevant environment. It's a research institute or it's an area where it's going to be used, and that is where technology development will happen. And the third is the business development. So business development is actual system in actual environment. So all these three parts of knowledge development, technology development and business development will comprise from TRL number 1 to TRL number 9. Let me now talk about each of those to understand what are these three verticals and what are these TRL 9. So a very standard figure now being used for explaining the TRL framework that you can easily find on the internet also. So technology commercialization game, the success of business development phase depends on the strength of technology development exercise. So technology development is very important, but before that one has to do knowledge developments. So in turn, the technology development in turn will definitely depend on basic understanding of this system, basic understanding of the design of different components, different system, technology that goes into that. So knowledge development is the key at the bottom of the pyramid, based on which the technology development will happen, and then lastly the business will get developed on this technology development. So knowledge development stage is very important, and this knowledge development stage has to be done in a kind of a research institute or an academic institute. So let's understand these TRL levels. So if I talk about TRL 1, this is the very beginning of the scientific research that you do, and the idea that you get maybe the innovative idea, maybe a disruptive idea, or maybe just incremental idea. One did not have to have a disruptive idea all the time. It can be very small incremental idea also. So this is a very beginning of a scientific research related to the idea that you want to develop a product. In this stage, the basic principles of the technology are observed and are reported. For example, I just found a new material for a new application. A discovering new material that has potential to be very strong, and possibly I understand if I make a new material or alloy of one or two material, and possibly it has got relevance in the environment that I would like to ultimately use. So first of all, discover this new material and possibly test it for the properties that I want. I want it light, I want it to be dense, I want it to be heavier, I want to be thermal conductive. For example, I want it to be resistive, I want to have it very high specific heat capacity, etc., etc. So all these parameters actually should be known to me, and the knowledge has to be grown about on this technology material that I am going to talk about. Then comes to technology TRL2. The TRL1 was basic principle observed. The TRL2 is now technology concept formulated. At this stage, I will see practical application of the basic principles are identified, and the technology concept and potential use cases are formulated. So if I am talking about material that I have talked about, I will possibly think about, can I use it in lightweight airplane part, for example. If I want a lightweight, and possibly have to have that much of mechanical strength or electrical strength, I possibly would start thinking about, can it be used in airspace? Can it be used in airplane? So now I will formulate my technology concept, and then airplane is one of the applications, but it could possibly have an application in other fields also. So from that, once I know these parameters, I will start to go to TRL3, where I will say, in this stage at TRL3, I will do experiments on this material to see that it satisfies all my requirements in terms of properties. So that will give me a proof of concept. So in this stage, I will do some experiments, I will do property measurements in the light of what I want basically, and I will prove that yes, this is feasible concept. That means it has got all the things that are possible to be applied later on in a, let's say, airplane, if I am talking about that as an application. So it means that I will create a small sample of this material and test its strengths, whatever I am talking about, in my laboratory. So in my laboratory, I would have done this knowledge development, which will have TRL1, TRL2 and TRL3, where I have developed a proof of concept in the laboratory. So all these developments have happened in my laboratory only. From here now, having done the knowledge development, I will go for a technology development, where I will go for a TRL4, where I will validate this technology in my laboratory. So in this stage, the technology is further developed and validated in the laboratory setting to demonstrate that the technology works as expected. All right. So in this example, I am talking about a material. I build a prototype of a small aeroplane, for example, a very small aeroplane, of course, but I will use this material. I will develop this prototype of the airplane, but I will use this material and test it under the various conditions in my laboratory only. So I will see that in what way the airplane is subjected to different conditions, and I'll see that this material on this aeroplane, for example, it's a door. Let's say it's a door of a aeroplane. A door of aeroplane has got a lot of expectations in terms of properties, because that is always a moving component, up and down, isn't it? Open and close and things like that. So I'm talking possibly about the material of that aeroplane, and therefore I have to do this technology validation on a small aeroplane in my again possibly it could be in my laboratory only. So TRL4 is technology validated in laboratory, and if I go from now forward satisfied that I am satisfied here, I will go. Otherwise, a lot of people will return from this place and say that no, it cannot be validated for whatever reasons. Then I will forget about this or change the base material. But if I am happy with this TRL4, I will go to TRL5 and say technology validated in the relevant environment now. In this case, at TRL5, the technology is tested in a relevant environment that simulates real world conditions. This step bridges the gap between laboratory validation and real world application. For example, in this case, I will create an atmosphere which actually aeroplane sees, and different atmosphere, different environment that it sees. So installing this prototype part on a test aircraft and conducting flight tests now, on experimental basis, of course. I am doing now some flight tests, and if it doesn't matter if this small aircraft, breaks or doesn't satisfy all my conditions, but I am actually installing this prototype part on a test aircraft and conducting flight tests to see how it performs in the air. So, I am actually going in the air, of course, in a limited environment, and I know all the risks associated with this. So, having passed this TRL 5, I will now move to TRL 6, where I will try to demonstrate this technology in the relevant atmosphere at TRL 6. Right. So, this is a demonstration now. Actually, I have done the validation first now. At TRL 5, I will now demonstrate it. This step includes more rigorous testing to ensure that technology works under real conditions. So, conducting multiple flights, not only one flight, right, conducting multiple flights, maybe in monsoon, maybe in windy conditions, that is what it sort of sees, and I will conduct multiple flights with the test aircraft, and this is test aircraft again, to demonstrate that the new part consistently performs very well. So, technology development now has gone from laboratory, material has gone from a laboratory to a prototype of aircraft, then I got it validated in my relevant atmosphere, but having done that thing, I have gone to a very rigorous testing of this aircraft in multiple different environments under real conditions. So, I have conducted various flights, various kinds of flight in different atmosphere, in different environmental conditions, and not only for 1 unit but maybe 10 units also, conducting multiple flights of this test aircraft to demonstrate that new part consistently performs very well. So, at this stage I can say my technology has been developed. So, first imagine again, I have started with knowledge development, then I have got, based on this knowledge, I have developed the technology, and again that developed technology is in a peculiar environment. Having done this now, I now think that TRL 6 has been achieved, that means it gives results under a different environmental condition and my technology works. So, here I will be serious now, and at this case or little earlier also industry people can be approached, and possibly they can think about having a business case out of this. So, if I say TRL 6, I am sure your product is really ready in the atmosphere that you have studied this, and possibly it's a good case for business development. So, at this time, if you go for an entrepreneurial venture or you go for a business incubator, for example, you can actually have mentors and think about having a business around this technology that you have developed. So, here I come to a TRL 7 now in a business atmosphere, maybe it's an industry or maybe it's a business incubator, but maybe it's basically going to be seeing the actual environment now. So, TRL 7 I am going to talk about, where this step involves testing of the actual conditions where the technology will be used. For example, using the new part on the commercial flight now. Till now I was actually restricting it to some test prototype aircraft, but can I now go from here to a commercial flight and with possibly real passengers and cargo to ensure that it works reliably. So, now I have got a TRL 7 when I am actually working on a system prototype demonstration in operational environment, right. Earlier it was a relevant environment, but now I am going in on operational environment where I am actually putting all these technologies on a commercial flight. So, TRL 7 actually sees operational environment, and I am taking now risks, associated risks of having business development around this prototype part that I have developed. So, TRL 7 is basically the system prototype and demonstration of it in a operational environment. So, TRL 7 is a very high case, and it's likely that this will going to be now mostly commercialized. When I have done all that thing, then I go for further important business, because I have to make a number now. I possibly have a scaling possibilities also, and TRL 8 is all about system completion and qualification. So, this stage involves final testing and evaluation and ensuring that the product being developed meets all the requirements and standards for operation. So, now I require certification. If you have got a bio healthcare equipment, of course, it will require all that certification from relevant authorities. Similarly, here I am going to basically have aircraft and everything. I will of course require certification. So, I basically now think about government certification for airworthiness of such a thing, right? So I will now go for all the certifications required at TRL 8, and then TRL 9 is basically going to be actual system proven in the operational environment. So here is complete commercialization. TRL 9, if you have reached that, congratulations, all entrepreneurs should actually strive to work to reach this objective reaching TRL 9 as early as possible. So if you have reached there, fantastic. The technology has been successfully deployed now and is proven to work in the real world. So for example, now the material I was talking about, the new aeroplane now, the part that I was talking about is now standard in all the new aircrafts and has been successfully used in many flights without any major issues. So this is a new part, has been adopted, let's say commercialized by different industries who are working in this. So I can be an entrepreneur or I can license this technology to anybody who wants, but basically now it is ready for further business works. So these three things are actually, identified different TRL level, they are standardized, and therefore the moment I say I am at TRL 4, I know that possibly you have done the work in the laboratory, but yes, you got a possibility that this technology can actually be licensed and possibly see the end of the day, and it has got possibilities of getting it commercialized. So if I see all these three things together, I would like to sort of demonstrate and show that the technology readiness level will happen at three different places. As we talked, one is at lab, at the university or the research center. So for example, in IIT Bombay, in my laboratory, that could be demonstrated. I can demonstrate it to 2 or 3 laboratories because it can go from 1 or 2 or 3 laboratories also, or it could be a research center. If it's not an academic this thing, it's a research center also. The second part is from university with advanced research facility and pilot facility. So it's actually going to our more standard research facilities where you can do pilot and showcase that in a environment that you are talking about, this is working. And the third is of course the professional manufacturing setup and the relevant industry. So you can see the 3 different verticals at 3 different locations that I am going to have. First the knowledge development, second the technology development, and the third thing is the business development. So very important to understand at these 3 different locations, this knowledge development, technology development and business development happens. So I will say from lab to research center, lab, university, research center, the TRL 1 to TRL 4 will take place, and this possibly may happen around a disruptive research, or maybe it's an innovative idea, or maybe incremental idea, but yes, what you are doing is applied research. So very important that big universities now take up this applied research and conduct this research in their laboratories up to TRL 4 maybe, and then 4, 5, 6 or 5, 6 can happen in a pilot place where it could be possibly advanced, a place where I got advanced research facility and you do pilot production there, where the technology gets completely developed in the environment that you think that it will work in. Having reached there, I will say the 7, 8, 9 are basically the business development cases that we are talking about, where manufacturing, scaling, government certification, etc. will happen, and actually it will reach to the relevant industries. And this is what I will say as to 3 verticals that TRL 1 to TRL 9 will happen. Very important now, the TRL will have resources, actors and fundings. Now TRL 1 to 9 that we are going to talk about, you got this diagram which shows that it illustrates the interactions of various variety of factors that constitute an instance of technology commercialization. The bold red line, it represents the value of death that may occur between TRL 3 to TRL 5 or TRL 4 to TRL 6. When you talk about the knowledge development, it's fine because that happens in the institution, research laboratories, but the pilot is very important, wherein a lot of technology die, where you understand, no, this is not possible because we are talking about different realities, real environmental issues, wherein a lot of technologies actually will not cross this value of death. And this value of death is very important, and you can use this term. I mean, more than often you can see that this term is being used in entrepreneurial activity. What do you see in this graph? that the basic research is done using public money normally, isn't it? In laboratories and all that thing, and at a public institution like government labs, etc., etc. But the private investors, like the large business houses, are only interested in the commercial aspect of. They are not bothered about 1, 2, 3 levels. They were bothered about 7, 8, 9. The journey of the technology product idea between TRL 4 to TRL 7 is the riskiest place, what is called as value of death. In this region, while it needs heavy investments, the probability of success is very, very low. All right, so only 1 in 10, 1 in 100 sometimes can be successful, and no doubt it finds few takers. Therefore, once you cross the value of death, then comes the acumen of business, then come the business houses, and then comes more funding. But TRL 4 to TRL 6 is a technology related funding, and therefore you have to show, have you done a relatively better work to show that your technology works in different environment, different operating conditions, and that's very important. What complicates this further is the fact that these intermediary stages needed a combination of interdisciplinary skills. So once I am working in my laboratory is fine, that because only my laboratory skills are required. But when I want to do when I want to do pilot study, I require various other people, various other level. For example, I require IoT, I require sensor, I require data acquisition, I require data analytics, and all these interdisciplinary skills and expertise to navigate successfully as a product is most important thing, which may not always be available in the institution or a center where you work. So a lot of technology will die at this place unless you hand over to somebody else. So at this point in time, industry may take over, and 4 to 6 also can be done by the research part of the industry. But it's very important that industry sees the academics at an early stage where the co-development can happen, or academic and industry work together. That's the best case possible. And this handover has to be, unless this handover is successful, the technology will not see the light of the day, as you know. So if you are a researcher, try to pick up skills and partner. So herein we have to have a collaborative work. 4 to 6, I mean, I need to have somebody from controls, I need to possibly have somebody from chemical department, I need to have somebody who has got software understanding, I need to have somebody who understands sensor technology, I need to have somebody who understands safety devices, etc., in my product. And this value of death therefore is very important. So TRL 1 to 3 is what you do for a living, but TRL 8 to 9 are best fit to the men who wear suits. As we say, the commercialization happens, they make profit, and ultimately business makes a sense around here. While for researcher like ourselves in the academic institute, possibly will work up to 1 to 4, where you do a lot of knowledge development and of course show the proof of concept. In all addition, I will add TRL 0, and my approach is to add TRL 0, wherein it's very important to, before I go for this product, I will do in my own way the market analysis. Why am I doing this research? It's very important to understand in a technical institute that whenever you develop a new technology, it is required in the market, and therefore I will go and get a personal experience researching this technology close to the application end. Teaches me to start with a strong market analysis. Is there a demand for this product? If I am working on a product for this material, for this aeroplane that we talked about, is there a demand? Is it required? Many times the industries want this, or many times I have an idea and therefore I would like to sort of develop a solution first. But before I develop a solution, I have to understand the market requirement. So is there a demand for this product or a service that I am developing in my laboratory? What are the target markets and what are the sizes of them? If I want to become entrepreneur, then I have to know about what are the target markets and their sizes. Are there existing solutions? Again, if I want to develop something, is it completely disruptive, or there are technologies available as of now, but I have got an incremental age for it, possibly in terms of efficiency, in terms of weight, in terms of product design, etc., etc. I have to actually come out with those things. So actually first I should therefore do market assessment for potential for this technology, identify the potential competitors also, and understand what are the available technology in the market. And importantly, if I am developing something new, then determine the patentability of the technology also, because I have to protect my innovation, I have to patent my innovations, and that is what is going to give me an edge while I go for funding and further of course when I go for scaling. So I have to place my product in this technology landscape. In the available technology A, B and C, where do I come? I have to have edge over them in terms of cost effectiveness, in terms of market requirements, and of course in terms of innovation that I have done in my this. So market analysis is very important, and that possibly could be done before I develop further knowledge and everything. So before I enter, if I want to become an entrepreneur, if I want to do very important technology relevant to the society, I should do first the market analysis, and then only I will, after assessment only I will understand. So when it comes to determining the patentability of technology, I conduct a comprehensive search of existing patents, scientific literature and other sources to identify the prior art with expert support. Right, it's very important, and file the patent as early as possible. And then I should do commercialization strategy also. So having done this, I will go for a commercialization strategy, at least the starting before I really get into this product development. Do I want to myself become an entrepreneur? I would like to license this technology. That also I will have to have some understanding beforehand. So I have to have some commercialization strategy for this technology. It's very important to estimate the cost associated with obtaining and maintaining patent also. So one has to really explore different options of commercialization, conduct a cost benefit analysis of this technology, and develop a clear plan for licensing to other companies or spinning off into a new venture. So do I want to license this technology to somebody else and get a royalty, for example, or hold equity in a company, or I will develop a new venture myself? Then I should have all those important requirements for the market development for becoming an entrepreneur. All right, so I have to understand, do I have all the strategy planning with me? Can I be a real good entrepreneur? That you have to understand, and identify the potential risks and uncertainties associated with this patenting of a technology. You have to understand everything, and then first identify the market, place yourself in the available technology, and start understanding the commercialization strategy associated with this product. And that I call this as TRL 0 approach before I get into the knowledge development for a particular technology. I will now take a small case study from lab to market, and this problem development is basically to design and develop a ultra low temperature freezer or a cold storage, which is cheaper, which is easier to manufacture compared to the current options available in the market. And currently the ULT freezers are used for storing in blood banks, in pharma, food, animal husbandry, etc., where these products, when they are frozen at very low temperature, actually last long for months and years, depending on the product, of course, and they are of course expensive, and they are difficult to manufacture. So one has to understand what are the nitty-gritties of developing such product. Now what does this product consist of? It consists of two parts. It's like a domestic refrigerator basically, which has got a compressor and we got a storage devices or a cooling module. So it has got a compressor and a cooling module, as you can see in this picture. And the global size is big. The global market size is very big, $1 billion per annum, and therefore there is a scope for commercial players. But understand, it's a very high tech product, and not that everybody can get into. Earlier, of course, somebody comes, but the product has to be good. It need not fail over a period of time. One has to possibly go for annual maintenance also of such products. It has got two modules. One is a compressor module, and another one is a cooling module. The compressor has got oil removal system, then there is a heat exchanger involved, there is the expander from high pressure to low pressure, and what is most important is to basically correct product design so that you get a good volume available for keeping the blood packets, tissue packets, or whatever you want to keep it as frozen in this particular product. So if I talk about the case study of this, I have to start with TRL 0, and as I said, I have to understand the market size, and I have to also understand about my commercialization strategy. So in my case, my PhD student would like to take it ahead, and therefore he actually did a market study by visiting various hospitals and tried to understand their needs. So TRL 0 that he first came up with, and he did all the studies, and then of course he went to analyze the refrigerants, thermodynamics, associated knowledge development that one has to do. he had done. So all this TRL 1, 2, 3, uh, TRL 1 and 2 first, the knowledge development part he has done very well. And as I said, it involves development of a compressor module and the cooling module that he started to focus on in our laboratory. And then he went on to develop this compressor module, the cooling module. The compressors have got oil, we have to understand the requirement of all these oils. Then he went ahead to understand the expansion model, because the refrigerants that we want to compress have to be expanded from high pressure to low pressure. And very important is the third most important place where the lowering happens, or the cooling module. So what you see right now is the TRL 3, which is developed in our laboratory, and that was his PhD work, to reach down to very low temperature. So with these studies, he actually reached down to very low temperature of minus 200 degrees centigrade in the laboratory atmosphere. But what is commercial requirement is only minus 100 degrees centigrade. So he is working on those now to develop commercial module, and we have developed such a product in our laboratory and in a pilot atmosphere, which what we say we are ready at TRL 6. So we are looking at these possibilities for technology commercialization now. So you can see the two ULT freezers that I have developed. One is a TRL 3, wherein you can see a typical PhD student setup, a compressor module, and on the left side what you see is the cooling module, and right side what you see is the TRL 6 level, wherein we have got a technology developed as a product now, and in the relevant environment that it would see, that we have done a pilot, and pilots still in seeing the real world environment, real operational environment that we would like to, and then we are actually now posing for a business incubation and business development from this. So this is the case study that I showed from my own laboratory of refrigeration and cryogenics at IIT Bombay. So this innovation, that ULT freezer technology, can actually be done at various places. So what we did was design of the knowledge development, design, etc. was of course done in the laboratory. The determination of the refrigerants that we would like to compress and use in this case, of course, was done in the laboratory. Design of all the subsystems we did in our laboratory, while the fabrication was outsourced. We have got outside industry where fabrication can be carried out and can be given back in 1 or 2 weeks time. Having done that, we got a control systems now. We are using other collaborators who would develop control system for us, safety, data acquisition, etc., being actually worked out, and that has been done outsourced work to somebody else. Having done that, we'll assemble the entire thing, and this testing also has been carried out in our laboratory or in pilot place, which is also outsourced. Having done this thing, the last thing is now pilot that is being going on, and this is outsourced. So once we have reached this outsourced business, that means we are reached at TRL 6, and now we are actually marching towards the business development part, wherein now we are trying to go in a industry environment right now, where we would like to develop at least 25 freezers to begin with, and see that all of them show consistent results and they are deployed. They are deployed first to the friendly customers, taking their inputs, possibly we will have to do the changes. Up to TRL 3 that we did in our laboratory, TRL 5 or TRL 6 now, up to which we have gone, have been done in a pilot atmosphere, wherein we saw that it sees all the operational, all the relevant environmental conditions that it will work in, and now from here the deployment would start happening. So this is what I wanted to talk about. In summary, I will say what we talked about today is understanding the technology readiness levels for an entrepreneur to understand at what stage it is, and can we start expecting investment once he reaches certain technology 3 and 4. But what is most important to understand the value of death. So wherein it sees from TRL 4 to TRL 6, I talked about my approach also to have basically the entire market analysis and commercialization strategies to be done beforehand, before you sort of get into the big exercise of knowledge development, business development, etc. I talked about a small case study in relation to the ULT freezer development in my laboratory, and this is the summary of the entire thing. I hope you have gained knowledge into this. If you want to become an entrepreneur, please understand at what TRL level you are, and accordingly start taking decisions for getting investments, for reaching out to industries, and earlier the better that industry comes into picture, because they can increase your TRL level very, very fast. Thank you very much.